So this is the solution to quiz 1 from Unit 7. So the situation is that Beowulf is moving at a speed of half the speed of light, and there's his pair of chopsticks, which has a length of 2 centimeters in the rest frame. The rest length is 2 centimeters. So we want to know when Beowulf is zipping along at half the speed of light, how long does this length appear to be? Okay, so let's use the Lorentz contraction formula. So L, that's what we're looking for, the length in a moving frame, 1 minus beta squared LR. And well, we have all this information, so we can just plug in and see what happens. 1 minus a half squared, square root all of that, times 2 centimeters. So let's see, 1 minus 0.5 squared equals, so 0.75, square root that, 0.867, multiply by 2, and I get approximately 1.73 centimeters. So in the moving frame, Beowulf sees the chopsticks as being 1.73 centimeters, not 2 centimeters. All right, so the second part of the quiz is asking a different question. It says this. Let's write this. So the rest length is still 2 centimeters, but suppose Beowulf now sees the length of the chopsticks as being only 1 centimeter. How fast is Beowulf going then? So we don't know beta. That's what we're trying to figure out. So again, we'll start with a Lorentz contraction formula. And I want to solve for beta. That's the algebraic task at hand. So that's going to take a couple steps, but nothing too crazy. So maybe the first thing I'm going to do is divide both sides by LR. I'll do that over here. So L over LR is 1 minus beta squared square root. So I've got beta inside a square root sign, and I want to get beta by itself. That's what I need to do. So what I can do to get rid of the square root sign is to take the square of both sides. And if I do that, square and square root, those undo each other. So squaring both sides, I have to square everything on the left. And squared square root, that undoes each other, minus beta squared. All right, so I want to get beta by itself. Let's move that 1 to the left by subtracting 1 from both sides. Then, again, we want to get beta squared by itself. I'm going to want to take a square root, but this minus sign makes me a little queasy. Let's multiply through by minus 1. Just flip the signs of everything. That's also a legal algebraic move. So I'm going to have minus L squared over LR squared. The minus becomes a plus, and this minus becomes a plus. So then our last step is to take the square root of both sides. So because I want to get beta all by itself. So square root and squaring undoes each other. And I'm just going to write this as 1 minus blah instead of minus blah plus 1, just because to me that looks better. So I'm going to have 1 minus blah big square root equals beta. That's what we wanted. We wanted to solve for beta. We've done it. Let's plug in a number and numbers and see what we get. L, that's the contracted length in the moving frame. That's 1 centimeter squared over LR squared. That's its rest length. So this is 1 over 2 squared. So let's see, so 1 squared is 1, divided by 2 squared is 4. That's 0.25. 1 minus 0.25 is 0.75. Take the square root of that, and I get 0.867. Just round that up to 0.8. So this tells me that Beowulf would have to be going at 0.87, or 87% the speed of light, in order for the length to be halved, so that the contraction was so much that the length of the chopsticks is now half the original length.